Okay, guys, I'm gonna go a little bit in a different order because my chapters are listed based on the book, and the ebook has the dyeing and printing before finishing. So I'm gonna start with dyeing and printing. There's a lot to cover, so I'm gonna try to go a little bit fast. So today we are gonna cover dyeing. So when we make fabrics first out of yarns, we have no color on them. They usually have this raw muslin fabric type of color, and you have to dye them to different colors if you want to use them in fashion, right? So we can dye fabrics using colorants. There are a lot of different types of colorants. There are natural dyes, there are synthetic dyes, there are pigments. And the goal is to produce an appealing color that is not going to wash off when you're wearing or when you're laundering. It's going to stay, and it also should be uniform throughout the fabric. But there are, of course, environmental issues, sustainability issues with colorants, because a lot of colorants are chemicals and they're bad for the environment. Now, when we talk about colorants, there are two kinds, dyes and pigments. And dyes can be natural or synthetic dyes. The main dyes that we use are acid dyes, azoic dyes, basic, direct, dispersed, reactive dyes, sulfur dyes, vat dyes. So those are different kind of dyes that you can use to dye fabrics. This will be our guide from here on. This is a fabric made with different types of fibers. So every column here is a different kind of fiber. So this is acetate, modacrylic, triacetate, cotton, and so on. And they dyed them to different type of, different colors using different type of dyes. So we're gonna refer to that fabric sample for each color. There are a couple terms that you need to know. Metamerism is when a color matches with one light source, but it looks like a different color at another light source. So when you check fabrics, usually what you need to do is put it under this light box. And the light box has switches where you can switch and use different kind of lights so that you can see if the fabric color is the same under all these different lights. And this is important when you're making garments, because when you make garments, you have to buy a huge roll of fabric. So when you're making 10,000 and you use one roll, and then you run out of the roll and you have to use another roll to make, the next t-shirt, where maybe you're missing the sleeves for the next t-shirt. So you use one roll for the body of the t-shirt, one roll for the sleeves of the t-shirt. Now, those rolls have to have the same color, otherwise your t-shirt will have different color sleeves. So when you get rolls of fabric, what you do is take a sample of the fabric and you put it under the light box and you check it against the other rolls of fabric to make sure that everything matches, it's all the same color. But some fabrics can look different in different light sources, so you kind of have to know. There's also a Bizold effect, which is when two or more colors merge into one new color. So sometimes, you have this kind of look intentionally. A lab dip is a sample that is prepared by the finishing mill, by the dyeing mill, and they have to prepare that so that you know which color you're trying to match all your fabrics. And there are a lot of different colors and shades. Like if you're making a red fabric, there are different shades of red. So you need to know which shade of red you need to dye. So for that, there's a lab dip that is prepared, and you give that sample, and every roll of fabric that is dyed has to match that color. And if there are different shades, usually what you have to do is you have to sort all of those rolls that have different shades. Some of them cannot be used at all. Some of them you will have to use it for something else. There's another reference for colors, which is the Pantene codes. Pantene has those color codes. And for example, if you're producing sweatshirts for Walmart and you're a company in China, you need to know what color you need to make those sweatshirts. And for that, Walmart product developers are going to send you some color samples. But the color samples have to be sent by mail into China. You know, it's a long process. But what you can do instead, as a product developer in Walmart in the United States, you can say, well, we want all of these sweatshirts to be in 320 Pantene color, which is the violet color. So we want everything in that exact shade. So, you know, it's not gonna be this color, it's not gonna be this color, it's gonna be this exact color from the Pantene catalog. So the Chinese producers, manufacturers will go to their Pantene catalog and they'll find that color code and they will try to match the fabric to that color. So that's kind of how it works in the industry. When you're producing something, you use those standard color codes, and Pantene is a standard that is used all over the world. So if you say 320 Pantene, everybody knows what shade the color is. When you're coloring it, of course, you can also dye fabrics at home by hand, but you have to watch a couple things. One, when you dye it, you have to be able to rinse all the excess dye, because the fabric will only pick up a certain amount of dye. Everything that is in excess will wash off every time you launder, but you have to rinse it off separate from all your other clothes. Otherwise, the excess dye will kind of bleed into your other clothes. So you dye your fabrics and then you wash it off to get the excess color out of your fabric. Wash down is you wash it again and you start losing color. So that's called a wash down. This is color loss that happens over time. Pigments are also used to dye fabrics. These are not necessarily the same as dyes, because dyes kind of get absorbed by the fabric and color the entire fabric. Pigments are not absorbed by the fabric, and this is good for fabrics that do not have good absorbency. So you can use pigments that kind of glue or bond onto the surface of the fabric. We actually call it adsorbents, not absorbents. So the pigments are usually on the surface of the fabric. They don't get absorbed into the fibers. Pigments have a lot of different ingredients. One is opacifier. Those are the elements in the pigment that produces the covering power. Thickener is something that prevents the migration of the paste, the pigment dye. Thinner is a thinner, you know, it keeps the paste semi-fluid, kind of like a paint. I mean, you can think of this as your wall paint. There are sometimes anti-bleeding agents that eliminates the halo effect on your fabric. And then the actual color pigment is the one that adds the color. So you're using pigments which also have all these other ingredients to make it a very successful dyeing process. Softeners are also included, because when you use pigments, it kind of hardens up your fabric. So you use softeners to make the fabric softer. Now, as I mentioned, dyes are actually incorporated into the fiber when we use them, unlike pigments. Dyes make a chemical reaction with the molecular structure of the fiber. They get absorbed into the fiber. So the colors that you get with dyes are usually a lot better. They look more uniform. Pigments, you can actually feel the pigments on the surface of the fabric usually. These are, this is an azo dye molecular structure. So this section here is called the chromophore, and that is oxochrome. So those are the components of a dye. The chromophore part is the colored part of the molecule. This part is the part that allows the bonding onto the fabric. Now let's start talking about different kinds of dyes. I won't go into too much detail, but There are acid dyes. Acid dyes are used to dye wool, silk, nylon, spandex. These are water soluble, and they were originally developed only to dye wool and silk. They give bright colors, but they don't last very long. Every time you launder your products, you may lose a little bit of the color. And they have poor light fastness. Now, there are two terms that I didn't mention. Color fastness is a property of fabric that that makes the fabric keep the color for a long time. So if we say a fabric doesn't have good color fastness, that means the color keeps getting lost when you launder, when you wash. Like every time you wash, your color starts fading a little bit more. So that kind of fabrics don't have good color fastness. Light fastness is when they fade their color with sunlight. So if we say poor light fastness, that means, the sunlight will fade the color. So acid dyes have that a little bit. They have poor light fastness. There are a lot of different colors that you can get with acid dyes. And this is a good example of our initial fabric sample. So you can see all these different fiber types and how much they picked up the color. So you can see silk and wool actually picked up the color the most, and nylon a little bit, rayon and cotton just a little bit, but all the other synthetic fibers, they really didn't pick up any color with acid dyes. So acid dyes are harder to dye those type of fibers. There are azoic dyes. We use those for mostly cellulosic fibers and also silk and nylon. So cellulosic fibers include cotton, rayon, and so on. They do produce bright shades, and you can do the dyeing at low temperatures. So it's a chemical reaction, and you have to know what kind of temperature you have to use to dye a fabric. Certain fibers can be dyed at lower temperatures. Certain fibers require a lot higher temperatures to pick up the dye. So with azoic dyes, you can do it at low temperatures. They have great color fastness to light, to laundering, to bleaching. If you do a lot of rubbing of the fabric, then they will fade a little bit of the color, but in general, they're pretty good. So this is our fabric sample again, and you can see which fibers picked up the colors better. Again, rayon, wool, silk, cotton, those are the only ones that actually picked up a good amount of the color, and then all the others kind of stayed in that low yellowish shade. Basic and cationic dyes, these are the oldest type of dyes, and we can use those dyes to dye acrylics, polyesters, a lot of the synthetic fibers. Acrylic fabrics have excellent color fastness to laundering and washing, and dyed cellulosic fibers usually have poor color fastness to these kind of dyes. So you can see how different fibers picked up color. So for all the samples so far, I was showing that most of the cellulosic fibers, which are hydrophobic, hydrophilic, they absorb, they have good absorbency, they were absorbing a lot of the colors, but the synthetics weren't really absorbing anything. But you can see that with basic and cationic dyes, the synthetics also pick up a good amount of color here. Polyester didn't really get a lot. Olefin is always hard to dye. Triacetate, not so much, but everything else picked up a little bit. Acetate is also a little bit on the lighter side. Direct dyes are dyes that we usually use for cotton, rayon, linen, and all the cellulosic fibers. And they have good color fastness to light and to dry cleaning solvents, to rubbing, to fumes and pollution. But these are an expensive type of dyes. And you can see that cellulosic colors, again, rayon, cotton, these can pick up the colors really well. They have strong dark colors. Wool and silk are okay, nylon is fine, but you see the synthetics again are staying very light. So this fabric is being dyed to basically this kind of color, And you can see that those type of fibers didn't even pick up anything. It's almost like, you know, they just got dirty with the dye, but didn't really pick up the color. Dispersed dyes are another type where we use them for acetate, triacetate, acrylic, modacrylic, polyester, you know, a lot of the synthetics. These can fade with pollution and fumes and so on, but generally speaking, they're good dyes. They require high temperatures, and they have excellent color fastness to laundering, and also to dry cleaning solvents, to crocking, rubbing, to sunlight, to perspiration, and so on. So you can see a lot of the synthetics actually picked up color in this one. Triacetate, acetate, you know, those are the ones that usually have a hard time picking up color. Olefin, again, is still pretty light. It doesn't pick up so well. Rayon and cotton, you see that dispersed dyes are used for synthetics mostly. So rayon, cotton, the cellulosics are not really getting a lot of good color in this case. Reactive dyes, these are another kind of dyes that we use. These are a little more eco-friendly, and we use them to dye cellulosic materials. They have great color fastness to sunlight, to washing, perspiration, crocking. But of course, if you put bleach, you know, this kind of dye will totally get lost. And you can see how the colors are picked up. Again, cellulosics pick up a lot more of the colors. Silk picks up pretty well. The synthetics don't really pick up reactive dyes really well. Sulfur dyes, we also use these for cellulosics. I mean, cellulosic fibers are generally easy to dye with anything because they are hydrophilic. They absorb dyes and moisture really well. These are a little cheaper, and they don't produce very bright colors though. So when you use these, you don't get a lot of bright colors. They do have good color fastness. But sulfur dyes, the problem with sulfur dyes is that it weakens the fibers. So it dyes the fibers, but it also makes them weak, and it starts to wear and tear really easily. So you can see example of this. This was dyed with sulfur dyes. Of course, it was also not dyed properly. So you can see that the sulfur kind of weakened the fibers, and they started to tear easily. Wet dyes, these are also used for cellulosic fibers. They are water insoluble, but they are changed to a water soluble form for dyeing. So one of the most popular wet dyes, and actually a natural wet dye, is indigo. This is what we use to dye our denim fabrics. And denim fabrics are generally made out of cotton, so wet dyes are used to make denim. Some wet dyes are synthetic, and they have great color fastness to laundering, to light, to chlorine, perspiration, and so on. And now we are done with dyes. We did talk a little bit about pigments, and I said pigments do not really get absorbed by the fabric. So we actually use pigments usually when we are doing solution dyeing. And if you guys remember what solution dyeing is, when you have the solution to make a synthetic fiber, you actually put the pigments in the solution so that the fibers can come out with the color itself. So instead of making raw colors with yarns, you're actually spinning the yarn and making the color at the same time. So pigments are much better to use for solution dyeing because pigments are good to dye materials that are not hydrophilic, that do not absorb easily. For example, olefin is one of those fibers that don't pick up moisture or water or dyes very easily. So the best way to dye olefin is to put the pigments into the solution before you dye them. Pigments have excellent color fastness to light and bleach. They're not very good with rubbing because they are on the surface. This is a summary of everything that I mentioned with different types of dyes and different types of fibers and how they are dyed and how they react to different ones. So if you guys ever want to dye something at home and you have some fabric, you need to know your fiber content of the fabric. And then when you go out to buy the dyes for them, just check which kind of dyes, and you can go look at this table to see which type of fibers will pick up colors the best. Now this is a solution dyed pellet for olefin, and we take these pellets, we melt them, create the solution to make those, and then you have colored olefin yarns. Okay, let's talk about the stages of dyeing. Now, you can dye fabrics, like I mentioned, you can dye them as a solution, and you can do solution dyeing, you can do gel dyeing. So when you have the solution, you add the pigments. If you're doing the solution as a gel, then you add the pigments into the gel, and you can dye so that your fibers come out directly from the solution when you're extruding the fibers and when you're producing the fibers for the first time. Or you can make the fibers first, and then you can fiber dye them. So fiber dyeing can be done when you have the fibers, they don't really have a color yet. So you can just have all your fibers and you can put them into the dye baths or wherever you're dyeing. So there are different kinds of fiber dyeing methods: stock dyeing, top dyeing, toe dyeing. I'll show you pictures of these. Or another way is you make your solution, you make your fiber, now you spin it into a yarn, and this would be mostly for cotton or more natural fibers like cotton, wool, and so on. You have the fiber, you spin them into a yarn. So now you have your yarns. So you can do yarn dyeing, and you can yarn dye in a skein, in a package, in a beam. So I'll show you pictures of these as well. So you just basically wind your yarns on a package, or you may have it as a skein. So I'll show you some examples of this. And another option is you take your yarns, you fabricate, create a woven fabric or a knit fabric or braided fabric, whatever you want to make, and then you dye it as a fabric. So your fabric comes out in a raw color, and then you just dye it. So we call it piece dyeing when it's in fabric form when we dye. Or the last stage is product dyeing. So when you actually take your fabric, you make your garment, and then you dye your garment. So that would be product dyeing. Okay, so let's talk a little bit about each. You guys know about solution dyeing. We just said, you just add the pigments into the solution. This actually is probably the best way to do it if you want the colors to remain in the fiber. So the colors don't come out easily when you solution dye, but this is not the best way to do quick response products. So, if the fashion is changing quickly, then you can't go back and change the color because you already dyed the fiber as a solution. You can't just change it later on. So whatever color it came out is gonna be in the garments. And solution dyeing is an expensive way of dyeing. So these are solution dyed modacrylic fibers. This is a canvas fabric made out of modacrylic yarns. The Sunbrella brand is actually a popular brand that is used for outdoor umbrellas and things like that. And this Fire Cyst is the registered trademark, and you just dye this as a solution and make these colors. So you see that this color is picked up from the solution before they extruded and made the modacrylic fibers. This is an outdoor upholstery fabric made out of olefin, and the yarns that are used here were solution dyed before they were woven into this fabric. This is an artificial turf, and they solution dyed this as well. It looks like it's olefin. Gel dyeing is when you add the color into the chemical bath after the fiber has been extruded. but before the fiber coagulates, so it's still in the gel form. So gel dyeing is basically you have the fiber extruded, but it hasn't dried yet. And it's only used when you're doing a wet spinning, because wet spinning, remember, we are extruding the fibers into a chemical bath. So you're actually adding the pigments, color pigments, into the bath where the fiber is supposed to get extruded into, and it coagulates inside that bath. Fiber dyeing is when you're dyeing the fibers before we turn them into yarns. So stock dyeing is when you dye raw fibers. Top dyeing is usually used for dyeing worsted wool fibers. And toe dyeing is usually used for filament fibers. And remember, I told you that we usually cut filament fibers into short staples because we blend them with natural fibers. So when you have to do that, you usually toe dye them, which means you dye them as a filament and then you cut them into staples. So that's called a toe dyeing. This is a stock dyeing of wool. So you have all the loose wool fibers. I'll show you some better pictures from iTextiles, but you basically have this dye solution here, and you're just sending all the loose fibers into this so that you can get the colors on the fiber before you turn the fibers into yarns. This is a stock dyed wool fiber. These are flock yarns that are used for suiting. This is suiting fabric, and all these yarns that you see in different colors are fiber dyed before the yarn was made, so that in each yarn you have all these like different specks of color. This is another fiber dyed wool. So the fibers were dyed, and then you spin it into a yarn. So the yarn has all these different colored fibers, and then you make the fabric. This is a plain VU fabric called tweed, because tweed fabrics are generally made with those fiber dyed wool materials. Fiber dyeing has much better dye penetration, because when you're dyeing things as a fiber, you know, all the colors are picked up much better. They're not very suitable for quick response products, again, because you're dyeing it too early in the production stages, and you can't make changes quickly to these. And it's also more costly than yarn dyeing or fabric dyeing. So the earlier you do, the more expensive it is in general. Yarn dyeing adds the color at the yarn stage. So, for example, this knit fabric uses colored yarns. So you have these green yarns and the white yarns that are already colored, and then you knit them to make the garment. So this is a yarn dyed fabric. You're not making the knit fabric first with raw yarns and then coloring it later. Yarn dyeing is also better penetration. Again, the earlier you do the dyeing, the better the penetration is going to be. The later you do, like, for example, if you make the garment already and you dye it as a garment, of course, there will be parts of the garment where it's not going to pick up the colors so well. Thick yarns and highly twisted yarns, of course, also don't, because they are so compact, the dye doesn't get through them very easily, so they have a little less penetration. So these are all yarn dyed fabrics. You can see, you know, if you see a fabric with a lot of stripes, things like this, these are usually made out of yarn dyed materials. So the yarns are dyed, and then you make these fabrics, because it's hard to dye a fabric into all these different colors later on. You know, if it has stripes, it has to be yarn dyed. This kind of stuff, yarn dyed. Now, when you're yarn dyeing, you can have yarns on a cone like this, and you dip them into this bath with the yarn, with the dye, and this will color your yarns. This is kind of an example of this. You see that yarns are on these perforated tubes, and these tubes have holes on them. So when they're dipped into the dye bath, the color can penetrate all the way. But of course, you see that, like, because the yarns are all wrapped like this, sometimes it doesn't penetrate as well. Obviously, if you dye it as a fiber, it will be a much better penetration. This is called package dyeing, where you have the yarns on this beams, and the beams go into these containers, which will have the dye solution, and you close them, and of course it's heated generally because you need heat to pick up the color, and you dye them that way. These are skeins. This is skein dyeing, where the cotton yarns are all on a skein instead of on a bobbin or on a cone, and you just dye them. Now, these are dyed to multiple colors because they dipped parts of the skeins into different dye baths and created this kind of multicolored yarn. This is a twill woven fabric, 2x2 even-sided twill, and the twill design is done using these different colored yarns. So this is a yarn dyed fabric. Again, yarn dyed. Anytime you see any kind of stripes or designs like this on the woven structure, it's yarn dyed. This is a plaid made with yarns that are dyed as yarns. This is a denim fabric, yarn dyed. Obviously, the indigo and the white yarns are used later after the dyeing. Fabric dyeing is also called piece dyeing. This is once you make the fabric. These are much more suitable for quick fashion, fast fashion, quick response products. And dye penetration is an issue with these, but usually what you do is you have your whole fabric roll, and the roll of fabric goes into your dye bath, and you just like let it stay there, and then goes out, comes back in, kind of goes through this. This is called winch dyeing. This is a jig. So in this case, your fabric is kind of going into the dye bath, coming back out. And this is called pad dyeing, where your fabric goes in and then goes through these rollers, comes back, goes back. You know, so those are different kinds of fabric dyeing methods. These are piece dyed fabrics that are rolled out after dyeing. This is piece dyed. Again, you know, when you dye it as a fabric, you usually have just one color. You cannot dye it into stripes. So this is a nylon fabric, and that has been dyed after the fabric was made. This is a piece dyed woven fabric again. This is a piece dyed silk fabric. And you can see that, you know, because of the interlacing, you can not penetrate the dye to every part of the yarn. Sometimes, like if you pull up some of those fibers on top of these yarns, you'll see that the inside of that didn't really pick up any color, so those stayed a little bit white. So you always get those on-dyed areas when you make when you color fabrics like that. Union dyeing and cross dyeing are two different ways you can dye your fabrics. Union dyeing is when you have blends of fabrics, like a polyester cotton blend, for example, and you want to get the same color, then you have a problem because polyester doesn't pick up the color the same way as cotton does. But you have to do whatever you need to do to make sure that the entire fabric is one color. So union dyeing is trying to color something into the same shade, even though you have different types of fibers or different types of yarns. And it may sometimes be a multiple step process. So for example, you have a cotton polyester blend. Cotton can pick up the color at low temperatures, but polyester is going to require higher temperatures. So what you usually do is you first dye the polyester at high temperature, and then you go back and dye the cotton part of the fabric again to match the polyester color, or vice versa. So you have to use a combination of different types of dyes. Maybe, you know, you're going to have to use a dispersed dyes for one fiber and a reactive dye for the other fiber to get the same shade. So this is a 50% cotton, 50% polyester fabric. This is union dyed, so you see that it's just one single color, but both the color polyester yarns and cotton yarns picked up the same color. So you have a unionized color shade on the fabric. This is union dyed, 50% rayon, 50% polyester. Cross dyeing is when you have different type of fibers in the fabric, but each fiber picks up the color differently. For example, you have this fabric. This is the raw fabric before dyeing, and you use these yarns to create this embroidery. And the embroidery yarns are cotton, but the actual fabric is silk. So when you dye this fabric, you're using a certain dye that will only be picked up by the base of this fabric, and the embroidery yarns are not going to pick up the color. Okay, so it's this green shade. Embroidery yarns didn't pick up any of that green, so they remain white. So this is called cross dyeing, when you're trying to create a different color effect on the same fabric, which uses different types of fibers. So again, this is your raw fabric when you first make the fabric, and then you dye the fabric to this green, but the cotton yarns for the embroidery doesn't pick up any of the color. This is another good example of cross dyeing. So this fabric is made out of wool and polyester. The polyester is these white yarns here. The stripes are made with polyester yarns. And when you dye this, the wool picks up the color, the polyester doesn't pick up any of the color. And when you separate the yarns, and when you take your polyester yarns and burn them, you're going to see that they are melting, but your black yarns are going to form this crushable bead, which wool does when we burn the wool fibers. So you're going to see that, you know, these are different type of yarns, different type of fibers, and they all pick up colors differently. And this is a cross-dyed polyester cotton blend again. So some of these yarns pick up this pink color, the other ones stay in that greenish color. This is another cross-dyed plaid fabric. So when you first make this fabric, it looks like that sample I showed you. It looks like this raw color. It has no color. And then when you dye it, this is a polyester nylon blend. So only one of the fibers pick up the color. So this color is picked up by these type of fibers, but whatever these are, they don't pick up the color. This might be polyester yarns, the white ones, and this could be the nylon. Product dyeing is when you make the garment and you're dyeing the garments. For example, you have socks, hosiery, t-shirts, jackets, slacks, towels. You make those, the finished product is already done, and now you're dyeing it to whatever color you want. These are perfect for fast fashion products, quick response products, where you can change the fashions quickly, because, you know, let's say the fashion colors changed for the year. So pink is not the fashionable color anymore. The trend is yellow. Then you can, you're still in the manufacturing process for your jackets. Then you can dye your jacket into whatever the fashion color is. So that makes you make really quick changes to your product to catch up with the trends. Product dyeing is not easy to do for garments that have a lot of components. For example, if you have zippers, if you have a different lining, if you have sewing thread, you know, all of those are different type of materials, so they're not going to pick up the colors the same way. So when you're doing product dyeing, you have to be careful. Like towels, pantyhose, socks, those can be product dyed because there are no other components to them. But if we are talking about like a, you know, winter coat, obviously you cannot dye it after the manufacturing is done, because I mean it uses a lot of components. But knee highs, you know, not a problem. You can product dye these. A t-shirt, not a problem. You can product dye those. Carpets, you can product dye those. So these are just like different methods when you're dyeing. I did show you some of those examples of winch dyeing, jig dyeing, and pad dyeing. So those are just like different ways of dyeing your materials. When we talk about package dyeing, this is generally the dye bath is forced through the fabric. And then there's combination dyeing where you can have different methods combined. Okay, I showed you some examples of pad dyeing when you're dyeing a fabric, but if you're dyeing the finished garment, then let's say we're dyeing these t-shirts, you just put all the garments into this big dye bath, and there's a pedal wheel that is just turning so that the t-shirts all pick up the colors nicely. So this is called pedal dyeing. These are piece dyed fabrics, which means they are dyed after the fabric is made. Resist dye it's a way of dyeing fabric where you are intentionally not allowing the dye to enter the fabric in certain areas. Okay, so batik, for example, is an example of that. And so you put a hot wax on the fabric in your design, and then when you color it, the color is only picked up by the areas that are not covered with the wax. There's also tie dyeing. You are usually just tying your fabric in different ways and then dyeing it so that you prevent the colors from penetrating all the way in, and that creates the tie-dye effect. ICAT is another way of dyeing, tying the yarns to prevent dye penetration in certain areas. Okay, so this is all I have for dyeing. So let's just go to your iTextiles. So I did talk about solution dyeing, fiber dyeing, yarn dyeing, fabric dyeing, and piece dyeing. We said it's called piece dyeing, and there are all these different methods to dye your fabrics. And then when you're doing product dyeing, you can use pedal dyeing or rotary drum dyeing. So I'll show you a couple of those because I didn't mention rotary drum dyeing. We talked about solution dyeing. This is a solution dyed yarn. It's a synthetic yarn usually. These are solution dyed viscose or rayon fabric fibers. We talked about stock dyeing. These are wool fibers that are hand dyed with acid dyes. So they're still in fiber form, not turned into yarns yet. So in here, you have wool fibers that are dyed as a fiber, and some of the wool fibers are not dyed, and you mix them up when you're making the yarn, so you get this heather look. You know, so some of the fibers are dyed and some of them are not dyed, and you have this kind of look when you make the spinning and turn it into a yarn. This is a tweed fabric that is fiber dyed. So you can see the shades, you know, the fibers have been dyed and then you make the yarn after. This is a knit fabric made out of fiber dyed yarns. So the fibers are dyed and then you make the yarns and then you have this kind of look. These are yarns that are dyed in yarn form after fibers are spun into yarns. So you can see those colors already. This is a yarn dyed sweater. This is skein dyeing. So you have all these skeins. They're not on a bobbin. They're not wound on some kind of cone. They're just loose yarns. And you just dip them into the dyeing bath here. It goes through these cylinders. This is called package dyeing. I did show you those perforated cones, and the cones are put into this big dyeing bath tank. We talked about those. This is an actual factory setting where you have your dyes and your yarns are going into the dyeing baths here and here. I showed you that one. This is a good example of poor dye penetration. So if you pull out the yarns out of a woven fabric, you can see that certain areas didn't pick up the dyes really well because this was fabric dyed. So if you dye it as a fabric, when you pull out your warp yarns, you're going to see that, you know, there are certain spots on these yarns that didn't pick up the color because of that tight interlacing pattern, which doesn't allow the penetration of the dye. I talked about winch dyeing and jet dyeing. This is the winch dyeing. And this is the actual picture of winch dyeing. So you see the fabric is going through the dye bath, coming out, going back, you know, it kind of goes through that a couple times. This is called jet dyeing, where you have a jet here that is putting the color on, and it kind of goes through that process. So you see the fabric here. This is the dyed fabric coming out of the jet. So it kind of goes through all of these, and there's this jet that kind of sprays the dye onto the fabric, and the dyed fabric comes out. This is jig dyeing. So this is a roller that rolls the fabric into the dye bath and then rolls it out of the dye bath. So this is the actual picture of jig dyeing. So this is your fabric roll, and your fabric kind of goes in and comes out. This is beam dyeing, where you have a beam and your fabric is rolled on it, and it has a perforated surface. So you put it into this tank where it picks up the dye. So you can see an example of that. This is the beam, and you can see the surface of the beam here, and you have the fabric around it. This is called pad dyeing. So this is again your fabric. The dye solution is here, so it goes through these cylinders and gets dipped into the dye solution. These are examples of product dyeing. So product dyed hosiery. This is a denim pants, jeans that are product dyed. So you actually make the denim and then dye it as jeans. This is the raw denim, and then this is the colored denim. So because these yarns are already yellow, and then you dye it into this yellow color, you can't really tell. This is the petal. I talked about petal dyeing. So you have your finished product here, your jacket, your shirt, t-shirt, dress, whatever is being dyed, and the petal kind of mixes them up to allow it to pick up the color. This is another example of product dyeing, where you have this solution with the dye, and it's circulating to allow your fabric to pick up the color. This is a rotary drum dyeing machine. So this tank actually rotates as your fabric is being dyed inside it. It's actually also used for pigment dyeing of garments. We talked about union dyeing, to dye blends of fabrics into the same color. We talked about cross dyeing, to dye blends of fabrics into different colors. So these socks, you see that heather effect. This is created from cross dyeing. In this case, this is not even a blend. This is 100% cotton. So you have cotton fibers and you have cationic cotton fibers. And when the socks were dyed, the cationic cotton fibers were colored, but not the cotton fibers. So you get that heather look. This is another example of cross dyeing. This is a fabric with silk warp yarns and linen filling yarns. And when you dye it, you get this cross dyeing effect. Okay, so this is all I have about dyeing. And in our next class, we're going to talk about printing.